and welcome to this video where I'll be going through asymmetric encryption, one of the most secure ways that we communicate today. So what I need you to know if you're going into implementing this kind of stuff, and one of the key features that compares it to symmetric encryption, please watch my video before if you want to know more about that. But the list here, what is important to know that this is computational, more strong or takes longer time. So it is not as efficient as symmetric encryption, but it provides something more and more unique than the other. So ideally we have hybrid encryption which combines the both. So the reason why it's harder and why it's more computational demanding, it's because it uses some other operations than symmetric encryption, which symmetric encryption uses these XOR, multiply and small numbers, while the asymmetric encryption uses power and modulus to encrypt the ciphertexts, and this is mathematically harder to compute and makes it slower. So let's talk about the most widely known RSA encryption. So if we look at RSA, what is unique about RSA is that we have the private key we generate, and then the private key we can use. We can encrypt the message, and then we can use the public key to decrypt that. So let's go into a more specific way of looking at this. So as I told you before, we have the private key here. Then we have the public key. So this private key is supposed to be at the person itself who encrypting your message with that, and then the public key can use by somebody else to decrypt this in the other end. So we have a message that is one that Alice wants to send to Bob, who has a public key. Alice has the private key. She encrypts her message with the private key, and then she now has this message as a sealed message. So this sealed message can then be sent securely, or can then only be decrypted by Bob, who has this public key, and now he can read the message or open the letter. So also another efficient way, or this way of having private and public key, can be used when we have to sign something digitally. So if you're like, you bought a house and now you need to, or you have some kind of legal agreement, you have to sign it, and the authority needs to know that you are the one who signed this paper, or you are in a corporation organization, you're signing some papers. So it's very smart that we can do this digitally. And the way we do that securely is that we have this document that we are signing, and then we have and the other part has the document, but the other part needs to know that this document is signed by you. So it's not that it's not visible, but we need to, in order to provide the integrity of this document, and we know that you are the one who are signing this, we also use the private key and the public key. So to make this more efficient, we will take a hash function of this document to because it can be computational hard to encrypt with the private key, and what we need really to know is just that we signed this paper. So the content of this is not important. So we just need to get something that is deterministic, and that's, you can go to watch one of my hash videos where I talk about what hashing is, hash functions, and so we can use this and it can encode stuff, so it can be more easily readable, and then faster to compute and faster to encrypt with the private key. So when we use the private key on the hash here and the document, then we get a signature, and this signature is important. It is like your validation of signing this paper. So now it's signed. So this is Alice. She just signed her paper, and now Bob, he wants to know that did Alice actually sign this paper. So he does actually the same. He has the paper, he hashes it, he gets this very unique hash from, which should be the same as Alice. So Alice, so he also does precisely the same, but now he uses the public key to encrypt it, and then he should somehow get the same signature as Alice has. So, or she did when she encrypted it, when she signed the paper. So now Bob can take the paper and then compare it. They can send it to each other, and then then Bob can compare it and to verify that Alice did actually sign this paper with her private key. Because she has a private key and that is her public key, and by signing with both paper, they should get a digital signature that matches. So, or he uses